Okay, so we are recording this meeting, and so we are going to learn the half cell balancing. And this half cell balancing is by the in the acidic medium and the basic medium. And as I said, that this is a part of the redox reactions. Okay, so what is the first thing? First is you determine the oxidation numbers of each species. Determine oxidation numbers of each element in the reaction. Okay, so for the oxidation numbers, what will you do? You're going to follow the oxidation rules, right? So that's the first step. Next, you're going to determine which one of them got oxidized and which one got reduced, right? Oxidized and which one got reduced. Clear? Now, remember that you will have to do the calculations also when you're determining the oxidation numbers for those elements that can form more than one type of positive charges. So here I'm going to make a note of it. So all the D block elements, D block, so the transition and post-transition elements, post-transition elements, and so these guys, and then also the elements such as sulfur, phosphorus, nitrogen, okay, chlorine, bromine, iodine, and xenon. These guys can also have more than one type of positive charges, okay, or they can make more than one type of bond. So more than one type of bond, or positive charges. Okay, so therefore these elements you will have to do the calculations in this case for the oxidation numbers. Calculate. Okay, so based on the rules for the oxidation numbers. So that's one thing clear. Next thing, once you identify which one is oxidized, which one got reduced, you break them into two parts. Break the reaction or the equation into two parts, and these two parts are called the cells. We call them cells. So one is the oxidation cell and the other is the reduction cell. Now, in each, there is one is the oxidation cell, oxidation cell, and the other is reduction cell. You break them into these two parts. After that, what will you do? You are going to, in each cell, you are going to first balance the metals, with the positive charges, if there are metals with plus charges or zero charge, whatever they have, whatever the scenario is. So first, balance all the metals. Next, second, this is very important. So let's put those here. In each cell, balance first metals. Okay, metals and cations, those things. Next, second, balance oxygen with water. You're going to add water. Okay, as many oxygens are there, then you will have to add water based on the number of oxygens. Like water is giving one oxygen, so based on that, balance it. Third, you're going to balance the hydrogens. Now you introduce hydrogens. So hydrogens with hydrogen ions. Okay. After that, you're going to balance the charges. So the fourth is balance the charges. Now, how will you balance the charges? So you're going to balance the charges with electrons. You're going to add the electrons. Okay. Now that's where mostly it gets a little bit tricky, because students don't, like sometimes it's tricky. It's like a plus and minus thing, and sometimes. So keep this in mind, that whenever there is a reduction, you place the electrons. So here's a little cheat sheet here. Whenever on the reduction cell, you're going to place electrons on left side. Okay, that's like a little cheat sheet here. Next is on the oxidation cell, you're going to place the electrons on the right hand side. Okay, right side. All right, now this thing. Now remember, even for the electrons, we have to look for the common multiples and so forth. Common multiples. So if you have to bring, if there are 3 electrons on one side and 2 electrons on the other side, then you look for the common multiple, 6. So, you have to do just like regular balancing. Okay, now what does electron actually mean? Electron means -1 charge. Okay, so that way. Okay, now once you get that piece done, after that you come back and now you add the 2 cells. Now this type of balancing is in the case with where the acids are used. So see, you have already introduced the hydrogen ion. So that means this type of balancing is in the acidic medium. So acidic medium, you are bringing in the hydrogen ion. But the same thing also, hydrogen ion, the same setup includes even for the basic medium. Everything is in the same, but the hydrogen ion means, acidic medium. So that like suffices. But in the case, in the case, I have to put this here, in the case the reaction is occurring in a basic medium, then what do you do? In the case the reaction is occurring in the basic medium, obviously you are going to add the OH on both the sides. Okay. So this is for the acidic medium. In general, this is what you will do. But if the reaction is in the basic medium, then you have to do this one more step. Okay. So basic medium, then 5th step you're adding. And the 5th step here is you're going to add, actually, okay, maybe add I believe the electrons may be added. Maybe we have to see. Okay, add the OH ions. Okay, OH ions. So what do these OH ions do? These OH ions cancel out the hydrogen ions that you introduced earlier. So cancel out the hydrogen ions. Now, how do they cancel out? They make water. Now, there is already some water elsewhere. Remember, you introduced water here. You introduced water in this place when you were balancing oxygen. So now there's common water. So water on the opposite sides, wherever there is, opposite sides, if there is water, as many water there are, they cancel out. Okay? Clear? So that's one step you do. Last, you are going to add the acidic, so oxidation and reduction cells. Okay, you add oxidation and reduction cells. Now, when you add, what happens? The same sides are added. Okay, same sides are added, but opposite sides are subtracted. Opposite sides means they cancel out. So opposite sides, whatever, same species, okay? Same species. If on the same side, they will be added, but if they're on the opposite side, they will be canceled. and then you just add. But just make sure in the end you check. You check for the charges. They should balance out on both the sides. So they should balance on both the sides. If they don't balance, that means you have a problem. All right. So this is your main, rules for half cell balancing, redox method. Okay. Now, the problem that was given on the test, and that is this test. So let's do this problem first in the acidic medium. So you are given that Cr2O7, okay, -2 aqueous medium reacting with HNO2 aqueous, okay, and this is giving you Cr+3 aqueous, and that's giving you NO3 -1 aqueous. Okay, so this is the problem. So balance. So the question is saying balance by half cell method. Balance by half cell method. Okay, in very specifically, they will say acidic or basic medium. So here, this is the acidic medium. Okay, so what is the first step? Tell me. Just now, what should be done first? Balance what? Find, very good. Find the oxidation numbers on each. So find or determine the oxidation numbers on each. Now remember, chromium is a transition element. So we will have to find this. So Cr2O7 -2. So 2 times X, that's for chromium. Okay, because it's a transition element. Chromium is present in the transition D block. Okay, so chromium is where we will need to determine for chromium. So 2X plus 7 times what? What is the oxidation number of oxygen? Say that again. -2. Very good. -2. And since this is an anion, I mean, it's a polyatomic ion. So what should be the sum total of all the oxidation numbers of all the elements here? No, this is an anion. There's a charge. -2. Very good. Because this is not a neutral entity, right? Everyone got that? Okay. So 2X, 7 2s are 14, -14 is equal to -2. So 2X -14 +14 is equal to -2 plus 14. So this becomes +12. And here you have 2X. So 2X over 2 is equal to +12 over 2. And here you are canceling out the 2. Here 14 and 14 cancel out. So the answer for chromium here is chromium is in +6 oxidation number. That's for chromium. Okay. Next is HNO2. So let's get for HNO2 also. HNO2. Remember nitrogen also, it can vary. So hydrogen is always +1, right? For hydrogen. Plus, so for nitrogen, we are finding now here, plus X for nitrogen, plus 2 into what for oxygen? What's the oxidation number of oxygen all the time? -2. And then sum total of the oxidation numbers in this case is going to be 0 because this is a neutral species. So you have 1 plus X minus 2 times -2, that's 4, is equal to 0. X minus 3 is equal to 0. So X minus 3 plus 3 is equal to 0 plus 3. So X is equal to +3 oxidation number. Clear? Next is the Cr plus 3, we already know. And then NO3 -1. Let's get for this one. NO3 O3 minus 1. Here again for nitrogen. Okay, X for nitrogen plus 3 into minus 2 is equal to minus 1. X, 3 2s are 6, minus 6 is equal to minus 1. X minus 6 plus 6 is equal to minus 1 plus 6. That means plus 7. Okay, so nitrogen is in plus 3 state here, and nitrogen here is in the plus 7 state. And then the other chromium is plus 3 charge, which means the oxidation number for chromium is equal to plus 3. Okay, so we calculated these. We had to calculate these so that we can determine the oxidation numbers of the key species, all the species. Okay, so what do we see here now? So here is, pardon me? Oh yes, 5, sorry about that. Thank you. So nitrogen, so this, yes, this would be 5, positive 5. So nitrogen is positive 5, okay? And so here chromium is plus 3. So these are the, all right, good. Now, what do we see here? These are the main ones, main characters. So oxygen is always minus 2, so forget it. So what's happening to chromium? Chromium is going from plus 6 to chromium plus 3 state, right? Nitrogen is going from positive 3 to positive 5 state, right? So which one is getting oxidized and which one is getting reduced? Reduced. Very good. So this is reduced and other one is oxidized. Clear? Everyone clear for that this much? Everybody? The whole class? I didn't hear you. Louder. Okay. All right. Very good. Okay. So even if you do this much, at least you will get some points. Okay, but do it correctly. Okay, not like some people just like to put all the oxidation numbers here only, and then it gets very like messy. So show the steps like this I've shown you. Okay, now, anyways, what's the next step now? You tell me. What's the second step after you've determined this? 2 cells, right? Break it up into 2 parts or 2 cells, and that is, so the second part is that we will look into the oxidized and the reduced cell individually. And we have to figure out how many electrons are being exchanged. Okay, oxidized. So write down the whole piece, oxidized. So main thing here was nitrogen. So whenever you see the species of nitrogen, so we see the nitrogen HNO2 converting to nitrate. So oxidized HNO2 giving you NO3 minus 1. Reduced is chromium, dichromate to chromium, dichromate. Cr2O7 minus 1 giving you Cr plus 3. Cr2O7 minus 2, sorry, minus 2. Okay, Cr2O7 minus 2, and then this thing. Okay, all right. What is the first step? Once you break this up into 2 parts, one is the oxidized cell and the other is reduced cell. So what's happening here? Balance the metals. And so here we will see, so leave as it is because there's no metal here. So here we will see we have Cr2O7 minus 2. What are we going to balance here? The chromium. What should we do? 2. 2 Cr plus 3. Everybody get that part? Metal first. Simple, right? Easy. Not that hard. You're not even balancing the whole equation. It's just focus on metal to a metal. That's it. Clear? Easy? Okay. What's the next step? Balance the oxygen. So in this case, here we have how many oxygens? We have 3 oxygens on one side in the nitrate and only 1 oxygen on the HNO side. And we have to balance the oxygens by water. So water can give you one oxygen and we need only 1 more oxygen. So we are going to just put H2O plus HNO2 gives you NO3 minus 1. So in this case, you see oxygen plus 2 oxygen is 3 oxygens and this is 3 oxygen. So that balances. Clear, everyone? Clear? Easy, right? Now, let's look at the next one. In this case, also, we are going to balance the oxygen. So here, how do you balance the oxygen? There are 7 oxygens on one side. What will you do? Yes? There are 7 oxygens on the left-hand side. How can you balance those 7 oxygens? Yes? By adding water. Oxygen is always balanced by water, okay? So we have Cr2O7 minus 2 gives you 2Cr plus 3 plus 7 H2O. Agree to that? So if you look at it, now you have balanced here the oxygens. This is 7 oxygens and 7 oxygens. Clear? Chromium is balanced. Chromium is balanced. All right. Okay, next. What is the next step? Yeah. Now we are going to balance the hydrogens. So in the top case, how many hydrogens are there? How many hydrogens? On the top one, 3 hydrogens. So here you have to put 3 hydrogens. So you have H2O plus HNO2. So we need 3 hydrogens. And so for 3 hydrogens means 3 hydrogen ions plus NO3 minus 1. So if you look at it here, hydrogens. Oh, okay. So 3 hydrogens, 1 and 2, 3 hydrogens. Okay, let's look at the other one. The other one also, same story. So we have here, how many total hydrogens on one side? How many total hydrogens? 14, right? So what will you do? So this is 14 hydrogens. So this side, we don't have hydrogens, but we are going to balance them by. So 14 hydrogens. Got it, everyone? Plus Cr2O7 minus 2 gives you 2, not 3. 2 Cr plus 3 plus 7 H2O. Okay, 14 hydrogens and 14 hydrogens are balanced. 14 here, 14 here. Got it? So if you look at it, 14 hydrogens balanced, 2 chromiums are there, 7 oxygens on one side. On the other side, there are 3 oxygens, there are 3 hydrogens and 1 nitrogen. Okay, so all this is now balanced. All right, now what is the next step? Balance the charges. Okay, so let's look at the charges on both the sides. Here you see the charges. Water, What is the charge on water? Charge on water? 0. Very good. So this is a neutral, 0. Charge on HNO2. Charge on HNO2 also 0, right? Here you have 3 plus 1 charge. Clear? Plus nitrate. So plus 1 into minus 1 charge. Okay. So that's one piece regarding the charges. So we have to make them 0. So in other words, one side is 0 and on the other side we have 3 minus 1. What is that? 3 minus 1 is 2. So basically it's minus 1 plus 3. So this becomes positive 2. Okay. But we have to make this positive 2 a 0. How can you do that? That's where all that electrons. So there's positive 2 on one side. Remember, first of all, this rule that for the, where is it? Yeah, charges. Reduction cell, electrons added on the left-hand side. Oxidation, electrons added on the right-hand side. So this is the oxidized cell. How many electrons will be added? Plus 2, very good. Remember that plus 2 electron means, this itself means 2 multiplied by minus 1 charge. So in other words, this is minus 2. So plus 2 is and minus 2. Cancel out. Okay, so this becomes 0. Clear? Pardon me? What was that again? Who's speaking? Can you raise your hand? Yeah. Have to go on the other side? No, why? We have to make it 0. This is the oxidized cell, and in the oxidized cell, look at that, oxidation cell, add the electrons on the right-hand side. Oh, so yeah. And in the reduction cell, you add them on the left-hand side. Okay. And if otherwise also you look at it, why they need to put it on the right-hand side? Because here is a 0. You want to make it 0. Okay. And you have plus 2 charge on the other side. So plus 2 charge, you can, when you add electrons, you're basically introducing a negative charge. So plus 2 and minus 2 cancel out. So that becomes 0. Okay. So that is now we introduced. So basically now write down the final one. So here is the, what was that? H2O, yeah, write down this, H2O plus HNO2 gives you 3 hydrogen ions plus NO3 minus 1 plus 2 electrons. Clear? Got it? So just, I copied the whole thing, 3 hydrogens, nitrate, and 2 electrons. So these 2 electrons were added. These ones right here. All right, let's look at the scenario with the left one now. Charges again. 14 plus 1 charge plus 1 minus 2 charge gives you 2 plus 3 charge plus 7 into 0. Water will be 0. Charge 7 zeros. Okay. So here you have 2 threes are 6. So this is plus 6 charge here. Okay. And here you have plus 14 charge, and then plus minus 2 is minus 2. So this is basically 12 plus 12 charge, and we need to make it the lowest. What can be done? Yeah. How can you make it 6 on the other side? So you have to look at the lowest side. Remember reduction. You're going to add it. This is a reduction cell. Reduction cell, the electrons are added on the left-hand side. So how many electrons can we add on the left-hand side? So that, they balance out and become positive 6. How many electrons? 6 electrons. So if you add plus 6 electrons plus 12 and that gives you positive 6. In other words, this is going to be 6 times -1. So that is -6 plus 12 is equal to positive 6. And this becomes -6 plus 6 plus 12 is equal to -6. Oh, sorry, positive 6, sorry. So this one was positive. No. Sorry. What am I doing here? Sorry. Okay. -6 plus 12. So this becomes positive 6. And the other side is also positive 6. All right. Balanced. So how did we balance it? We added 6 electrons here. So this becomes now this equation. 6 electrons plus, copy the rest of the stuff. Plus 14 hydrogen ion plus 1 charge plus Cr2O7 - 2 charge gives you 2 Cr plus 3 plus 7 H2O. Clear, guys? So what do we see here? Okay, now we have something here. We have 6 electrons on one side, but we have 2 on the other. What can you do? We have 6 electrons on one side and we have only 2 on the others. What can you do? How can you equalize the electrons? Equalize the electrons, first of all. How? Common multiple, which means multiply by 3. So equalize the electrons by multiplying by 3. So you can get 6 electrons if you multiply by 3. That equation. Okay. Okay, so this means you have now 3, all of it multiplied by water plus HNO2 gives you 3 hydrogen ion plus NO3 minus 1. And oh, wait 1 second. Plus 2 electrons. Okay. So what do we get here now? 3 H2O plus 3 HNO2 gives you 3 3s are 9 hydrogen ions plus 3 NO3 minus 1 plus 6 electrons. Clear? So one side is this story, the other one. So we now have these balanced. What are we going to do next? Add the 2 cells. Now the electrons are balanced. So we brought in this 3. So now you are going to put them. Let's change it to a different color. Okay. So now we have 6 electrons plus C plus 14 hydrogens plus 14 hydrogen ions plus Cr2O7 minus 2. Okay. And that gives you 2 Cr plus 3 plus 7 H2O. Okay. So this is one thing. Next is the other one, which is 3 H2O 3 HNO2 gives you 9 hydrogen ion plus 3 NO3 negative 1 plus 6 electrons. Okay, and now add. So when you add, what you're basically now canceling out the common ones on either side or similar. Okay, so here we have 14 hydrogen on one side and 9 hydrogen on the other side. That means 14 minus 9 is what? 5. So now you're going to put 5 hydrogen ions here left over. Okay. And then you have water also. Look at this water. 7. So 7 minus 3 is equal to 4 H2O. Okay. So 4 H2O. All right. So now just add Cr2O7 minus 2 plus 3 HNO2, right? 3 HNO2, Cr2O7 minus 2 plus 5 hydrogen ions, right, is equal to 4 H2O, right? H2O plus 2 Cr plus 3 plus 3 HNO3, sorry, 3 nitrates, NO3 minus 1. Okay. And 4 waters, 3 nitrates, and 2 chromiums. Okay. HNO2, 5 hydrogens, and 3 HNO. Okay. All right. So this is balanced. But like I was saying, you should always check always. So what will you check? On both the sides. So bring on both the sides. Once again, break it up again. The reactant side. So this is the reactant side, and this is the product side. So the number of charges should be the same on both. So Cr2, so sorry, the reactant side and the product side. Okay, so Cr2O7 minus 2 is giving you negative 2 charge, and then 3 HNO2 is giving you 0 charge, and 5 hydrogen ions are giving you plus 5 charge, right? So what is this? Positive 3 charge on one side. Let's see this one. 4 H2O is giving you 0 charge. 2 Cr plus 3 is giving you plus 6 charge. Okay. And 3 NO3 minus 1 charge is giving you minus 3 charge, right? So what is this? You add this, what do you get? Positive 3. So this is how you check also whether you get your answer right or not. Okay. You don't even have to look at the answer key, but by looking this, if you get both the charges same, your equation is balanced. Clear, guys? I know it is a lot, but it is like, it really flows. I'm telling you, if you just follow the thing. So the tricky part is sometimes students get confused with here, electrons. All right. Okay. Now we will do the basic medium. Okay. Basic medium.